Next section of problems deals with taking the derivatives of the exponential function. So in its most basic form, the derivative of e to the x is e to the x. Really, that's the whole idea of the exponential curve. At any point, the tangent line to the exponential curve, its slope equals the y value. So the derivative of e to the x is e to the x. When that exponent has some function of x in it, then we say that the derivative of e to the u is rewritten e to the u the same as it was, times the derivative of u. This is really just the chain rule being applied to this original derivative. So when I look at part A here, I have x squared, a function of x, being multiplied by e to the 2x, also a function of x. That means I'm going to have to use my product rule here. As I'm doing my product rule, when I get to this e to the 2x, I'm going to have to use this version, which is really a chain rule. So let's begin. When I take the derivative, I do first x squared times derivative of second. When I take the derivative of e to the 2x, u is 2x, so I rewrite e to the u, e to the 2x, and then I multiply it by the derivative of u. The derivative of 2x is 2. I add to that second, e to the 2x, times derivative of first. Derivative of x squared is 2x. As I clean this up, 2 times x squared gives me 2x squared, e to the 2x, plus 2x, e to the 2x. I would absolutely be fine with you leaving this here if it was on a test for me. I'm pretty sure that Cengage will accept this answer, but if you were to look at problems like this, and you looked at how Cengage says that the answer should be, they're probably going to factor out a common 2x e to the 2x here. So if I took 2x e to the 2x out of both terms, dividing this by 2x e to the 2x, the e to the 2x would go away, the 2 would go away, and you get x squared over x, which just leaves you with x. I pulled out a 2x e to the 2x, that's this whole second term, so when you divide something by itself, you just get 1. Again, I think you're fine leaving it right here. I'm just showing that this is the way that you would get the answer that matches their example problems, basically by pulling out that common factor. When I look at part B, this is a very long problem. I have 1, 2, 3 different product rules to deal with. Technically, you could even call this a product rule, but since it's a constant, I really don't need to worry about it as a product. I can just keep that -4. But as I go through, this is going to give me 2 terms, this is going to give me 2 terms, this is going to give me 2 terms, and then I'm going to need to combine like terms as I go. So starting with the first one, x cubed e to the x. I do first, so I'm going to label it f prime of x. First is x cubed times derivative of second. Derivative of e to the x is e to the x. Plus second, e to the x, times derivative of first. Derivative of x cubed is 3x squared. Now to the next term. First, negative 3x squared times derivative of second. Derivative of e to the x is e to the x. Plus second, e to the x, times derivative of first. Derivative of negative 3x squared, the 2 comes down and makes it negative 6x. Plus first, 6x, times derivative of second, e to the x, plus second, e to the x, times derivative of first, derivative of 6x is 6. Finally, we're going to subtract 4 times the derivative of e to the x, which is e to the x, so this just stays -4 e to the x. We've done all our tough deriving now. What we're going to need to do is multiply out, make sure that we have the x and the coefficient in front, the e to the x behind, and then see what are like terms. So this becomes x cubed e to the x plus 3x squared e to the x minus 3x squared e to the x minus 6x e to the x plus 6x e to the x plus 6 e to the x minus 4 e to the x. This x cubed e to the x has nothing to combine with, so it stays. But by design in this problem, everything else really cancels. Here's a plus 3x squared e to the x. Here's a minus 3x squared e to the x. Here's a minus 6x e to the x. Here's a plus 6x e to the x. Finally, I have a plus 6 e to the x, minus 4 e to the x. 6 minus 4 leaves me with positive 2 e to the x. Again, this is where I would leave it. It's possible that they want you to factor out that e to the x. If I did that, I'd take out an e to the x and be left with x cubed plus 2.